Katariina Kari was with us last year, co-presenting with Mark Wallace on the concepts of SemOps and how that applied to the organization that she was with. It's similar to DevOps, but there's much more to it than that. In fact, Mark Wallace will be at a table called Agile Semantic Knowledge Graph Development. And so he can probably give you some more insights as to, how we're, adapting, our semantic delivery approach to the Agile aspect. And just to give you just a little understanding, Katariina will be talking about the various mapping languages to describe, not design, transformations for knowledge graph enablement. My pleasure to introduce Katariina. The floor is yours.
Hi, Steve. Thank you so much. And thanks for having me here. It's great to be back at this conference. Always love how most like the talks that I usually have, the ones at DCAF are the most nerdiest ones. So I'm enjoying myself and I hope everybody's enjoying this conference so far. What I want to talk today to you about is semantic modeling of data sources for data transformation. It's something I've seen during my work and during my past work, and it's just a kind of a suggestion on how I would actually like to do modeling for the knowledge graph when it comes to data sources. And the whole gist of my talk is if we semantically describe data sources, it drives the automation of mapping, and it produces also data catalogs, which you might hear from other sources as well, other vendors as well. But that's really what we need. And that's I'm coming from an enterprise knowledge graph background, so that's really the point of view I'm taking. For 6 years ago, I started to work at Europe's leading e-commerce platform for fashion called Zalando. And there I had roles such as knowledge engineer and ontologist. We developed, one of the things we developed was the fashion knowledge graph, but also some internal enterprise knowledge graphs were developed during my time. Starting from last year, September, I changed to the organization of IKEA Systems, which is the franchisor of all the companies that run the IKEA stores globally. One of the biggest companies to run IKEA stores is called Inka, but there are others as well, and they all license that IKEA concept and IKEA products. They're also the ones who are then running e-commerce stores. So the idea is we're building knowledge graph capabilities central to the franchisor, which then serves the needs of its franchisees. I have a research background in semantic web, but I don't hold a doctorate degree. I just was working in a research group as a research assistant when finalizing my master's degree in science and engineering. But I also happen to have a master's in music and arts management, and I spent, before Zalando, I spent 5 years as an entrepreneur in the space of digital means to engage audiences for especially classical music. And when I joined Zalando, my dream was to have a cushy IT job and to a part-time IT job, and then the rest of the time used to do like underground contemporary opera productions. But then the knowledge graph world took me by the hand, and now I'm here just being a full-time nerd. So I have two things I want to talk to you about today. One is this one project I did for Zalando on master data management, for which I actually have a blog post as well that I'm going to share later in the chat, so you can have a look. And when I was introduced to this master data project at Zalando, I learned about the traditional approach, which was the traditional approach is you have multiple heterogeneous data sources spread throughout the company. All these data sources kind of work with the same things. Like one of the things was the business customers that Zalando would have, and the same companies would be having slightly different roles depending on what part of the business they were interacting with. And each part of the business had their own data source. But the idea was we need to have a unified view of that business customer. So we need to consolidate these different data sources because they're all talking about overlapping things. And the idea is they have their logical data model and their physical data model, the LDM and the PDM. And then when you first understand your landscape of heterogeneous data sources, then you suggest the logical data model and physical data model for a golden record. So this golden record, and this master data project had a consolidated approach. This golden record was non-invasive, but it would store and copy from the data sources and also reconcile a golden record of the business partner, which would take in all the different kind of information from these different data sources. And when I looked at this, and I was people who had done master data projects for years and years explained to me what they're doing, I said, aha, you could do many of these things with the knowledge graph. And so I introduced the knowledge graph approach inside Zalando for the master data project. And that's what I'm talking about in the blog post. So the idea was that I actually semantically described each data source. They were all relational databases. So I basically created a model for tables and columns and databases. So here's the database, it has these tables, and those tables each have these columns. And I had that all described semantically. And then each of these columns I would map to concepts. And then I said, the landscape of concepts that is derived, that kind of comes up from all these data sources, that is ultimately the logical data model for the golden record. So those concepts are the golden record for the LDM. And if you, for example, want to use whatever, like a normalized relational database data model, then you can just calculate that physical data model from the logical data model. And so to kind of walk you through with the example, this would be the traditional approach, that you have data source 1, its logical data model, and data source 2, its logical data model, and then you write that golden record logical data model, and you have governance and everything. So this is like you'd first describe those 2 data sources with the LDMs, and then you would write and design that third golden record LDM. But I said, no, don't do that. Instead, use knowledge graph approach, which is semantically describe the first data source. As you can see here, address in orange bubbles, address line 1, and orange bubbles on the left, address line 1, 2, and 3. And since address line is something that really doesn't tell you what part of an address that is, it's just like 3 lines of an address information, I said that maps indirectly to the address concept, which is the blue one is a concept. And I'm just going to, some of you might notice that I'm using the Neo4j visualization. That was just something I did because for me, I have my own scripts for turning RDF into Neo4j visualizations. So I was just doing that because currently I find it's the coolest visualization. So I just wanted my thing to look good. But do not fret, I was not doing this with Neo4j, I was doing it with RDF. But then, so on the right, you have the other data source with the, again, 4 orange bubbles. Each one is a column, and this data source was a bit more descriptive in its logical data model. It has a zip code, city, country code, and street, and those map directly actually to attributes of this address concept. What might be really interesting for you to notice here is that not only did I describe the concepts as nodes, but also their attributes were nodes. The schema for the attributes were nodes, and the schema for the relationships were nodes. So this also is like semantically a little bit of a different model. The idea was really to be able to describe all the things that we needed in order to then generate the logical data model. And what we're getting out of this exercise is, out of the box, you're not only creating the logical data model for the golden record, which was really the only task I was given, but you also get a data catalog out of the box, because you have described your data sources and you have described how they map to business concepts or business vocabulary. You get the mapping from a system to golden record. So it's not just about like, this is the logical data model, but this is exactly how the data source maps to the logical data model. And you could get data lineage by just adding like one predicate from the data sources to each other and say which one is upstream, which is downstream for each other. So by adding that predicate to those different data sources, you could also get data lineage. And that I find is a much better data-driven approach to working with data sources. And this brings me to my next part of this talk, which is, hey, semantic web community, let's talk about mapping languages. So mapping languages, I don't know why, but I'm not buying them really. And I don't think we should be manually writing mapping definitions such as R2RML or RML. Tarkle, I don't know. I mean, Tarkle has other benefits for like quick like putting things together quickly using Sparkle, or treating like CSV as a Sparkle source. But at least currently my team is working with JSON files and we're using RML. And when I saw the team manually writing or suggesting to me to write manual RML, I felt we were doing something wrong. And I felt we were losing a chance to be data-driven and data-centric. So I think we should we should not design how to transform data from a data source into RDF. Instead, we should just describe that data source. And let me lay this out to you. So this is actually an example from like a just RML page. I forgot to mention the source of this page. I can do that later in the chat, or if anyone wants to ask me. But this is basically, if you Google RML, this is one of the things you will find. And here the example is, you have input data in JSON format. Then you have this big RML description here, and it basically says, kind of like names the source. There's a few things about the source, that it's a JSON file, and that this is like the local file path of the JSON. And then it basically tells you how to put together the triples. And then the output data is this kind of nice TTL or nice RDF file in TTL here, with this, like, because this is talking about Brussels as a city, so it creates Brussels as a IRA as a concept, with RDF type 2 schema, city, class, and then attaches a few bits of literals to it, which is all about like latitude, longitude, and country code. So this is basically what it's producing. And the idea is, traditional approach is a knowledge engineer writes this RML description, and this is how it looks like. Like, actually took some time to write, to draw this. And if I look at this intuitively, this doesn't tell me much. I find it. Anyway, I'm not a big fan of blank notes, to be honest, and I think, like, if you're using blank notes, you might be doing something wrong, but that's my personal opinion. You don't have to take my word for it. But I think like blank notes are not informative, etc. I know why people would be using them. I don't like to use them, but I don't I don't find that this is a very informative and definition of like, or it doesn't kind of give me more knowledge if I look at it visually. So here's my suggestion. Take the input data, treat it as it's your data source, and describe it semantically. Say that you have this data source called venue.json, and because it's a JSON file, the yellow would be like it's an RDF type of a JSON file. It has two root keys, which is venue and location, and those root keys then further refer to other keys such as latitude, longitude, or location refers to continent, country, and city. So basically, you're describing the key structure here semantically. So this is just the schema of the JSON, and I think it should be very easy to even generate this description of the data source, because it's quite straightforward programmatically to be able to even generate. You wouldn't have to even write this manually. Then the next thing you do is describe the mapping to any schema, a concept schema you already have. So we have this like definition of, we have the schema city, or we have this like from the schema.org vocabulary, we have the city, and we want it to be using these properties to get the latitude, longitude, and country code. So that's you, and then you take your schema for the JSON and map, just map, and say what is the subject and what are the objects. And then one more thing is, for anything you want to create as a concept and turn into an IRI, you need to give the instructions for the IRI, which is what's the namespace, and then how would you create that local name. And here I used a bit of a Pythonese approach of saying that just kind of take the name of it, or the actual value of it, and turn it into something. But this, you could I think you could take this, develop this a little bit further. This is just a prototype I hacked together quickly last week, or the few weeks before. But you could take this a little bit further and say, well, use the camel case function to turn this local name. So this is just in instructions, a recipe for how to create the local name. And then why should you do this? First of all, I think this one is much more clearer than this one. So that's why I would rather want to see this approach. Plus, you get the bonus things of a data catalog. So you're describing your data source. If you connect venue.json to any upstream, downstream, describing what is the upstream and downstream of this system, you get data lineage, plus you get context. If you have like in my organization, if there's a team responsible for creating this data source, then I could attach that information as well and say, this is a team, this is their email address, and they update the index every lunch break and every evening or something like that. So you could add a bunch of context to this data source. So what I'm also saying is, from this mapping of you have the data source described, and it maps to whatever schema you have for concepts, and this is the way to map it, this is the way to describe that, how to create the IRI, we can generate the RML. This can be generated. And I have a small demo for you that I'm going to describe, show you next. So let me just switch the kind of screen that I am sharing. Okay. So I hope you can see my Jupyter notebook. Just anyone? Yeah, you should be seeing it. Cool. So first of all, and I have this on GitHub, so I can share this link to you as well. The whole prototype is there. But let me show you. So what am I doing? I am just opening a few configs. I want to say that if it's a JSON file, this is the kind of description for this is all the things I need for the RML generator. Then I take in my input schema, and this input schema is, let me just show it to you on visual code. So the input schema is this one. This is the data source. Sorry, this is the data source definition of menu.json. So it's basically that blue and yellow data source description I showed you earlier. So it's taking that in. I'm using RDF-lib here for the ones who might be asking what I'm using here. And then I'm taking in the mapping in a different graph instance. So here's the mapping. City maps to the schema city class, has this namespace definition, has this local name pattern, and is subject of a venue JSON, and then all the kind of other latitude, longitude, country things I need to describe. So that's what I had in blue, in red lines in my graphical, in that picture with the data source described and the mapping. So I read that into this graph, into another graph, a mapping graph, and then I just define a bunch of namespaces so things look neat, and bind them to the ultimate graph that I'm creating, which is this graph generates the RML for me. So that's done. Then I have a few like helping functions that I need for this. One is I need to know this this like JSON. I need to know the JSON path for city, which is location.city. So I just need a function that, you know, if I give it a URI or RI for a concept, that is part of this JSON semantic description of the JSON file, it will just give me that path, that JSON path, because I need it for the RML, and a bunch of other functions I won't go into too much. It's just helping functions. And then I define the mapping concept. So what I do is, I need to use a Sparkle query just to kind of get the source. So let me just show you the Sparkle query. So what I need to do is, in order to, wait, let me just see where I'm launching this to. Yes, this is a Sparkle query against the data source. So I have the JSON described semantically as a data source. I need to issue the Sparkle query for that. And what I want to get the source itself, the source, so the source RI, its name, its file name, the type of the file, and the iterator information. So those are the things I need first to get from that. So I'm getting just a bunch of information about this source file, this JSON file. And then I do a lot of things that like basically look at these things and put them together, look at the mapping to create my object predicate object things for the RML. So basically all of this is about building those different concepts from the RML for the RML file. And then I write this, in the end, I write out this generated RML file. So this generated RML file does not exist yet here, but now if I push the button, voila, I have generated the RML file. And yeah, not so much magic as you would expect. But if we look at these things together, the result is this. This is what I just printed out from my graph and what I constructed using the description of the data source and the description of the mapping. And believe me, these have exactly the same triples. I mean, I could do like a fancy triple comparison, but it's the same triples. And that's really it. That's the demo. And now I'm happy to take any questions you might have, and I'll also post my links. So the first link I'm putting here in chat is the blog post on the master data project I did for Zalando. And then the other one is for the GitHub repository where I have this RML generator prototype. And I guess I need to look at Q&A. James, do you?
I will actually, I was watching kind of the order things came in, and so I'll post the first question that came in, and I'm just going to put it up on stage so that everybody can see it here.
So have you considered using Neo4j for the initial mappings and Neo-semantics to map to RDF concept? Neo4j works well in this scenario. You get the full visualization per set of nodes. Well, I think what I need ultimately here is a semantic description. I really need my RRIs. I need to probably, like, I want to use like a standard vocabulary. For me, it's very important to work. I would love to work with other people in the industry on like how we could develop describing JSON and other data sources, like what could be a standard vocabulary for describing or ontology for describing those data sources. So for that, I would really want to do the data RDF first. But I mean, for me, it's not a problem to then throw RDF into any kind of system that's visualizing. But I have like other opinions on where to use Neo4j, so happy to take that conversation offline and continue chatting about it.
Great. Our next question was a hand raised, so I'm going to call on Michael here. Michael should be able to hear you now.
Hi, thank you for that interesting talk, Katariina. Couple of questions. So it's very clear to me that if you're required to map things to RML, I agree with you. It's pretty ugly. I've had to do that type of thing. And so your approach is probably definitely a win there. So a couple of things. One, there are tools. I used one. It's now under the control of data.world, but I'm not sure if they're still using it. It's a UI that you can use that conveniently avoid all that ugly syntax and create mapping. So that's one thing I wondered if you had tried. But the other thing is, if you don't have to use RML, I mean, Tarkle is actually, the example you use would be very easy and straightforward to use with Tarkle. So creating a middle language does have some benefits, but it also creates more work. So I'm wondering what your experience is in terms of the trade-offs. Do people really want this type of thing? Would it be needed for Tarkle? Thank you.
Yeah, so I probably could use Tarkle to access the data, but I don't really want to access the data as such. Like I said, like I have more use cases describing the data source in itself than actually working with the data. Like I do have some also that I need to get that data from the data source and put it into my data graph and have populated with the knowledge graph, but that's just one thing. I have like 3 different use cases where I actually semantically need to describe the data source and just manage the knowledge about this data source, which was the context that I mentioned. What's the team responsible for this? How often do they update their index? And who should I, like, what's the email address for, like, if something's down or things like that? So it's like an enterprise need for that context information. And then I would like to be able to drive a data catalog out of knowledge graph. And I know data.world is really strong in that, and that's probably what their tool is doing. But then I have that third thing, which is I would also want to drive data lineage information in the knowledge graph. And for that, again, I need a semantic representation of the data source.
Thank you. That makes a lot of sense.
Okay. And then we had one other question posted that I'll pull up here.
So how does the data structure works underlying for actual data search and match? So if you have a lot of data sources and they are connected to central concepts of your company, so the whole point of this data-centric architecture is your company has a handful, like just hundreds of concepts that really describe the business as such. So you have those different data sources and they all map to those concepts. You'll be able not to only find one data source that has to do with a certain business concept, but all the different data sources that are about the same data concept. So I think that's how, like, the data search and matching, like, that's where the matching comes, because you now introduce your data sources as part of your network of your business concepts in the knowledge graph. I hope this answered your question.
Yep. And it looks like we've got a follow-up from the same person. There we go.
So what happens when data volume grows? Does this impact the semantic processing? So because I'm actually, like, this approach is more about the metadata of the data sources and not the actual data of the data sources. The data volume growth is not a necessary problem because, yeah, it's not about the volume, the amounts of data points, but it is really about the amount of data sources you have in your company. And well, they cannot be big data because somebody needs to physically put like a data source up and running and take care of its database and so on, and of the backend engineering. So that doesn't, like, that's not the problem. But the problem, like, it is still a very real problem, which is once we have described those data sources and we've generated our RML description or whatever description mapping you would do, you will most likely, if you have huge volumes of data, it might be really long to bring them into the data graph. And for that, I think I'm seeing still a lot of data engineering specific questions that we would need to answer. Like, would it make sense? Like, does it make sense to do batch operations on these data sources, or do we need to introduce some data streaming things? It's really not what my talk is about today, but I think the strategy for semantically processing your data source definitely is impacted when the data volume grows. So I guess the short answer for this question is yes. It does impact the semantic processing. It doesn't impact the semantic description of the data source, because I think from that description, not only can you create your RML mapping, but you can create any kind of data transformation pipeline logic that you would need. But it does affect the strategy for taking this data in. And then the question is, should you take that data into the knowledge graph? That's then the next question that I see.
Great. Got a raised hand. Dave, let's see, should be able to hear you now.
Yep. Thank you. Hey, Katariina. Very interesting.
Right.
I have a few ideas for where you might want to take this next, or maybe you're already there. Because I think you're on to something here. The first one, you said probably you could generate the initial map automatically. You're doing it by hand right now. And if you do that, one suggestion is pick up the data types. Because I noticed in your example, you mapped latitude and longitude to a string. That was probably a default. It'd be kind of nice to notice that they're floats or decimals or whatever. And then obviously, and I don't know if Laurent's comment would work, but it would be nice to graphically do the mapping. You know, literally drag and drop and all that kind of stuff. I realize that's another whole project. And then the final one, this is even a bigger extension, but even just a little bit of lightweight data profiling. So reaching into the data set, and this kind of goes back to your first example, when you had address 1, 2, and 3, you have no idea what those things are until you profile it. You know, 3 might be city, or it might be a person's name or whatever, but you know, you just do a little bit of lightweight profiling, and you could take the result of the profile, you know, just the shorthand version of that, and attach that back to your graph. So then you've got it forever. So
yes. And the fun thing is, I could also, like, additionally add to any kind of, this is an email address.
Mm-hmm.
I could also say, please run it by the email address validation function. And
Right.
then those functions for the data validation, they are also described in the knowledge graph.
Right.
So that's another additional
Yeah.
thing. And that's why I think we need to describe the data sources.
Yep. No, you're onto it.
Thank you.
Awesome. Okay, We had one other question in the Q&A that we'll throw up, and then we'll make our transition here.
Do not many use cases require instance data based on the meta model? So currently, like it's just that the way to work with these data sources is that you just take their data and create instances out of it in the knowledge graph. So it is true that most of the use cases will need the data points, the data instances, the data as such, the actual data from the data source, and whatever else you do with your knowledge graph. I'm just saying that because that's been the main thing, I think the industry has not thought that maybe this mapping is also actually has some value and should be kind of put on a higher level and a higher position in the knowledge graph, and not just be like a mapping, a technical mapping, but have like a semantic description. But the short answer again is yes, most use cases need the actual data, if I understood your question correctly. And then there are a few use cases that would also, like, especially for enterprise knowledge graphs, that would also need the metadata model, the information on the metadata model, or the meta model. Yeah.
Great job.
Thank you. And
Thank you.
I would love to get any contribution to the GitHub repository or to this prototype. I mean, I have a few, it's still a very simple JSON. I would love to get a bit more contribution and or any ideas how to take this further. Already, I got some nice ones from Dave already. Thank you. Thanks for having me.
Very good. I know these thought-provoking types of things like this get our juices flowing. So I know you'll have plenty of people that will be active in that.